Let's talk about Stokes theorems in R3. This is a class of theorems that relates the integral of the derivative of a quantity over a subspace to the integral of the quantity over the boundary of that subspace. The point here of these theorems is that you get to trade a derivative in the integrand for a boundary in the space you're integrating over. The types of subspaces of R3 that we can deal with: lines, surfaces, and regions. The boundary of each of these, the boundary of a line, is its two endpoints. The boundary of a surface is a curve. And the boundary of a region, let's give it some topology here, is the surface around it. That looks appropriately like a surface. The Stokes theorem relating lines, involving lines, is the fundamental theorem of line integrals. And it says if you integrate the derivative of a function, in other words, its gradient, over a line, this is equal to the integral of the original quantity, the function, over the endpoints, which is just a difference here, f at the end minus f at the beginning. The Stokes theorem over surfaces is actually called Stokes theorem. And it says that if you integrate the flux of the derivative of a vector field, the vector derivative, through a surface, this is the same thing as integrating the line integral, the vector field itself, over the bounding curve. Lastly, for regions, the Stokes theorem for regions is called Green's theorem. And it says integrating over a volume, over a region, the derivative of a vector field. This time we're going to take the scalar derivative of the vector field, the divergence. This is equal to integrating over the bounding surface the vector field itself, its flux through the surface. Again, in all of these, the common theme is that you trade a derivative in the integrand for a simpler thing that you're integrating over. So you trade a derivative for a boundary.